I'm ready. All right, we are live. Good morning, good afternoon, good evening, good night, wherever you might be in this wonderful world. My name is Matt Kimball with Moor Insights Strategy, all caps. I am joined by Paul Smith-Goodson, Mr. Quantum, and Will Townsend, Mr. Security and Networking, the king of security and networking.
And telecommunications.
And we don't care about that. That's still all kind of.
We don't care about 5G, even though AT&T just finally launched their standalone nationwide network.
Who's AT&T? Anyway, hey, we're here for episode 51. Not a prime number, though it looks like it could be one. To talk about a whole bunch of things. We're going to be talking. What are we going to be talking about, guys? We got SailPoint, we got Intel, Quantum, Marvell, Microsoft, IBM, and AMD. And we're coming on the heels of the New York Yankees getting knocked out of the AL Championship Series or the AL Division Series. I am so happy. I woke up a new man. So anyway, I just wanted to say congratulations to every non-Yankees fan out there because we're all celebrating.
I'm sure your wife is probably happy about that event.
What's that?
You're a changed man. I said, I'm sure your wife was probably happy about that.
Yeah, there are so many jokes I could throw in there. I stumbled, Paul, because there were too many jokes. I didn't know which one to queue up first in my brain. Sorry. Hey, before we get into the news of the day, two things. Got to do the disclaimer. This is not for financial trading, so don't take anything we say as investment advice. This is just three nerds sitting around talking. But there was some news that broke this week that I wanted to hit on real quickly before we jump into the meat of what we've already established as our topics. And that is AMD and OpenAI entered into a partnership announced on Monday. What a way to wake up. Whereby OpenAI would consume upwards of 6 gigawatts worth of GPUs from AMD, which is anywhere between 3 and 5 million GPUs over the next 5 to 6 years. And in return, AMD would effectively grant 160 million shares or 10% of its company, 10% equity to OpenAI. Technically, it's a penny a share, so I'm sure that's an SEC thing. But I wanted to get your all your thoughts. Maybe Paul, we can start with you, kind of shift to Will, and I'll jump in on the back end. Just real quickly, I want to kind of get this out there because it's such big news and everybody's talking about it. What do you think about this, guys?
I mean, I think it's a good deal. I mean, even though it's not a big share issue in terms of money. I mean, the number of shares, of course, is a lot, but I think it's a good deal. The more we can get these big companies partnering together, I think the more product we're going to get, and the more unique products that we're going to get out of this. So I think it's a good deal. I mean, there are so many things happening right now, different companies partnering together, and especially OpenAI, and they're spreading a lot of this around. It's just, it's really hard to keep up with everything.
Yeah,
it really is.
Yeah, I wholeheartedly agree. Yeah. What are you thinking, Will?
Yeah. So from my perspective, man, we live in very unconventional times, right? When we look at the federal government's investment in Intel, when you look at the agreement that's been struck with NVIDIA and AMD on licensing to China, and that payment that flows back to the federal government. And this is pretty unconventional, but what I like about it, I mean, certainly, and we've talked about NVIDIA numerous times. I mean, they're leading, obviously, the AI charge. And from my perspective, this really puts some wind behind AMD, right? Because, with their GPU platform, they've been the second, kind of place entrant here, and I think it's super interesting. I like the deal structure, and and I kind of read through it, and Obviously, certain things have to trigger for
Mhm.
for that equity to flow back to OpenAI. But I like it. And what I also like about this is that it's going to strengthen AMD's competitive position.
Mhm.
And I have a famous quote that I like to use all the time, and it's like, competition breeds innovation. And so a stronger AMD and certainly a stronger Intel with what we're seeing there is a good thing for the industry. It gives customers flexibility, gives customers choice.
Yeah.
So I like the deal. Very unconventional, but again, we live in very unconventional times.
Yeah. I think it's unconventional in one sense, in that it's certainly creative. But I think in AI, we're seeing that there's a lot of creativity going on, right? NVIDIA invests heavily in CoreWeave, and then CoreWeave buys NVIDIA's GPUs at a huge discount, and then or leases them. I can't even remember which one it is, and then pays NVIDIA for that, right? Um, there's a market seeding exercise that AMD had to go through with their GPUs if they're going to be successful, because NVIDIA's just owned it. You're right, but I think the bigger thing for me here is ROCm. So what has held back AMD is not its GPUs. I mean, you could look at even the MI355 versus the B200, and you could argue it's a superior architecture. It's got a lot more HBM. It's when you kind of peel back on the architecture itself, it looks pretty impressive, but it becomes almost not unusable is the wrong word, but ROCm has been difficult to get seeded into the marketplace because CUDA owns it. ROCm's a great software platform. It's a great stack.
Yeah.
CUDA owns the market. So
Right.
to me, the bigger play here is OpenAI is going to take, like Azure did, like everybody does, they're going to take ROCm, they're going to make some optimizations for GPT. They're going to contribute those back into the open source community. More importantly, those 3 to 5 million GPUs are all going to be using ROCm. So OpenAI is going to propagate the adoption of ROCm out into its user base, which opens up the aperture a little bit, or opens up the gates a little bit for AMD to get in. And I think that's where AMD's biggest opportunity is.
Yeah, in CUDA, when you look at, how long that tech stack has existed, right? It's over a decade, right? Maybe even longer.
Mm-hmm. It's been about it's probably about 20 years now. Yeah,
almost 2 decades, right? And what I like about CUDA is just like you can enter that tech stack at any sort of point, right? And there's like this forward and backward compatibility, and there's been this huge, 2 decades in the tech industry is like a lifetime.
Yeah.
In any other industry, little tongue tied there, but yeah. So this, great insight, Matt. Great insight.
It's just gonna be fun to watch. But hey, congratulations to AMD. Really smart maneuver there. Congratulations to OpenAI. They just got a bunch of free GPUs and 10% of AMD. So
pretty good deal, man.
160 billion shares is hard to turn away from. So. Right. And congratulations to NVIDIA, because this is going to motivate them even more to continue that. That's the thing about them. Even though they own high 90% of the market, they don't act like a market leader. They act like a challenger. And this is going to motivate them to continue that. So anyway, we'll move on. Sorry. Let's jump in. Let's talk about SailPoint. Can you tie the SailPoint point you have here, Will, with the Yankees losing last night?
I thought you were going to ask me about my creative headline here.
That's a good. That's a good one.
Well, the Yankees did suck wind.
Yes, they did. That's good. I like it.
All right.
I like it.
Cool.
Thank you.
Yeah, and so and the wind does not refer to the hot air, Matt, that you often share on this podcast, and with me personally when we were at IBM earlier this week.
Yeah.
Anyway, okay, let me move on. So SailPoint. So I've known CEO Mark McLean for over a decade now. In fact, many years ago, I actually applied for a job but he's the founder and co-founder and CEO. They have traditionally been an identity governance and administration security play. So they're not an Okta or a Ping. They're not focused on what I consider to be sort of commodity single sign-on, that sort of thing, but really manage entitlement and that sort of thing. I would argue that the company's sort of been stuck, for the last couple of years. They launched their Atlas tech stack 3 years ago, and very robust, doing what it needs to do, making SailPoint a leader in IGA. But now agentic frameworks are bringing sexy back to identity, right? Yeah. And one of my big observations at RSA conference was, hey, someone's going to have to figure this out, right? The whole notion of provisioning and access, and the interaction between task agents and orchestration agents and all that sort of thing. So there's a lot of focus on this. So it was probably an easy prediction to make. You've seen Agency, which was incubated by the Outshift team at Cisco, moved to the Linux Foundation. They've gotten more support behind that. You're seeing a lot of focus from companies like Palo Alto Networks acquiring CyberArk to not only fill the gap in their overall platform strategy with identity, but to leverage that for their agentic framework. And now what SailPoint is doing, because they've had this rich history in IGA, at Navigate in Austin, which I attended a week ago, they launched a purpose-built agent identity security solution. They've also woven in deep observability and a data access security layer, which didn't exist before. And, from my perspective, this is going to put wind in their sails, because, SailPoint is a very nautical,
it took you a long time to weave that in.
Yeah, it took me a long time to get to that one, right, Paul? But at the end of the day, what I love about this is that now you've got all of these companies, including SailPoint, that are focused on this, and this is going to get figured out. I mean, it's super complex, but I really love what the company is doing. I'm going to continue to spend more time with them, and so I'm super impressed that we're because we got to figure this piece out to drive scale, amongst these agentic frameworks. So I don't know, Matt, but I mean, I know that security touches your coverage area as well, but what do you think about all that?
I think agentic is going to change this world like nobody has kind of has even begun to imagine. It's funny, you hear all these estimations and all of these predictions from analysts, pundits, tech leaders, and I think they all soft shoe kind of the real impact of agentic on the enterprise. And I like what you're saying, and I like the approach that SailPoint is taking. I wonder sometimes as SailPoint goes down its agentic strategy, Palo Alto goes down its agentic strategy, Cisco goes down its agentic strategy, and they all do.
Yeah.
Who owns the agent orchestration and agent coordination? I mean, if we're following agentic AI the way people are saying it's going to go, what is to prevent SailPoint from being kind of the all-up enterprise security control plane that can also manage? So security is super fractured, right? I'm going somewhere with this, by the way. I promise. Security is super fractured, right? What is it? 100 and something products in the typical enterprise, right?
Yeah.
We're going to be agent-based at some point. Who's going to be the Uber agent that manages all of these, not disparate, but all of these different solutions or different agents that are out there?
Yeah.
There's nothing to prevent, Solar or SailPoint from managing Palo Alto's agents, Cisco's agents, and coordinating with them and being kind of the orchestration and control layer for security across the enterprise. Because that's the beauty of agentic, right? All of these different agents can talk to each other through MCP or through some other protocol, right? So it's going to be, that to me is kind of, that's the bigger question I have around all of this is where does the market go, and who owns
I
that
kind of
market?
look at it a little deeper and a little from a different perspective. I mean, I think Agentic is really a good technology, and I think it's going to be improve productivity and everything. But I kind of worry about it. It's really we're seeing basically an explosion of non-human identifications out there.
Mhm.
There's going to be tens of billions of these things, wandering around, making autonomous decisions, and they can create their own sub-agents.
Mhm.
And it's could be difficult to track. I mean,
Mhm.
it's almost like what we used to consider to be a perimeter for an enterprise. It's kind of disappearing. I mean, the identities that we used to identify with are, the humans and machines, and now we've got AI thrown in there, and accessing all the scattered data and the applications that are in place. So, it's kind of worrisome when you kind of
That's kind of my point, though, Paul. Is and there are going to be new companies that come along that help kind of manage that, right? It all falls under the guise of security. But what is that one master? Who's going to have the control plane? Is it SailPoint that has the control plane that manages, proliferation of vulnerabilities and otherwise, and new problems that arise out of agentic AI, but also can help orchestrate all of those point products that are helping to protect.
Yeah, and I think, Matt, where you may have been going with this is that, SailPoint, I think will have a challenge, because when you look at a Cisco or an HPE or a Palo Alto Networks that really owns a big chunk of the footprint in the infrastructure, they have the scale, right? And so I think it is going to be a challenge for, like a SailPoint that doesn't have that real estate, right?
Yeah.
But they've proven themselves, with traditional IGA, and so it'll just be really interesting to see how all this shakes out. I think there's room and there's enough TAM for all of these folks to leverage it. But certainly, like I mentioned, Palo Alto Networks and their acquisition of CyberArk, that that's their design. I mean, they want to own it, right? And they're the largest cybersecurity provider on the planet. And now with identity, they complete their platform play. So
and that's the thing. But I think AI is disruptive enough, especially let me rephrase that. I think agentic AI is disruptive enough that it can allow a SailPoint to be far more competitive than it otherwise would be against these giants. Because you just have to look at it differently, right? Instead of like, how do we double down on what we've done? It's how do we step back and look at this bigger world and offer kind of that one pane of glass that can tie into all of these other. I think it enables it to compete against a Palo Alto far more than it could today. But anyway, I'll shut up, and I don't want to go too far because I know we have a hard stop today. So. And Paul,
I'm already violating what I agreed to before we got started. I'm being too verbose, so I'm gonna tighten it up.
Oh, my kids tell me all this time, they're like, "You talk too much." I get it. We're all that way, right? So,
right.
I don't know.
Let me just put in one more piece in here that kind of follows up with what I said. Is that there's going to be looks like a disconnect between identity context and security context. Identity is, who is the agent? Who does it belong to? What's it doing? And security is, what are they doing, and what data are they accessing? And so I mean, it just kind of makes me nervous that we're doing this. And
well, I think it's time for the preppers to stand up and start getting ready for the world to get taken over by the robots.
Yeah.
Hey, I'm going to step out of order here. We're going to jump into Paul next with, here we go. Yep. Only Paul can come up with these. Only cheaters bid with quantum. What the heck is that, Paul? Did I lose?
What?
What is this? Only cheaters bid with quantum.
It's not really cheating.
Okay.
It does involve bidding. There's a collaboration between a company called HSBC, which is Hong Kong, Singapore Bond Corporation, I think, close anyway, and IBM. And the research is about making algorithmic trading better because the bond market and stock market, all these places use some type of algorithm to do the trading. This was to finance is supposed to be one of the leading candidates to become the first domain to actually take on quantum in terms of trading and everything. So this automation is to help traders, do bond trading. It was initially trading began back in the 50s with the New York Stock Exchange to do kind of basic things for traders, and in a couple of decades later, in the 70s, and that's when algorithmic trading came along, and they used computers to automatically execute trades that were programmed. And the main problem is that in today's bond market, is that trading is trying to determine the probability that when they send a bid out, what's the probability that's going to be taken up. And that's what this whole research project was about, is to improve that bid improvement. And actually, at the end of this research, they actually came up with a 34% improvement, which is huge. I mean, when you look at bond trading, there were some issues with the experiment. The system basically is composed of they've got a quantum computer in there. They've got 4 dealers. They've got 3 dealers that are doing like routine bids and everything. They're programmed to do the routine bids, and they've got another dealer that's hooked up to the quantum computer, and the quantum computer manipulates the data and provides this one dealer with fill probability estimator, and so that they measured one dealer out of these 4 dealers on it to come up with this. It's going to be something pretty amazing, I think. It's definitely going to help in the bond trading, and that's probably going to be one of the first ones that we really get a quantum application built on. So I'm looking forward to it.
It's funny because, Monte Carlo simulation has been used a lot for the high frequency trading, right? It feels like to me, it's not an evolution, but it's that kind of next wave of, what that online trading actually looks like. And I don't see where people are actually even going to be necessary.
Mm-hmm.
A trader's desk is going to be just a bunch of keyboards.
I got involved with some interesting trading back in the 80s. I was at MIT for some Unix classes. The professor, John Donovan was his name. He ended up killing himself. But the guy was brilliant. He had we spent most of the time in his class talking about his 24-hour trading and analytical system that he had running in the basement of the MIT building. And we spent most of our time working on it. He was running Unix. It was DECVAX, but he was making a lot of money with that. So
DECVAX, that's funny. That's funny. All right, let's move on. Just in the interest of time, I'm sorry, we're just running so fast here. Let's hit on something really quickly. So,
you get 60 seconds, Matt.
Yeah, Intel comeback tour continues. I'm going to be really quickly because we talk about Intel quite a bit, but I had the opportunity to go out to Phoenix at the beginning of last week not this week, but week prior to visit the Intel manufacturing facility and get a technical deep dive on its client and server roadmaps. And all I can say is I think Intel's been back, but I think the market's starting to get how back they are. What I can say with confidence is 18A is real and it's producing. 14A is coming right along. And the roadmaps I saw for client and server are pretty darn impressive. Just real quickly, so I'm not a manufacturing nerd, but they gave us a tour of their fab, their manufacturing facility, which is a bunch of fabs, and we toured the 18A fab, and I have to tell you, I was absolutely amazed. So this manufacturing facility is 750 acres. I can't tell you how big the actual factory itself is. It is huge, like indescribable huge, like Tesla huge. And, those factories work 24 hours a day, 7 days a week. There is no such thing as a weekend. We toured it on a Sunday. I must have walked a full mile throughout that factory. I could count on two hands the number of employees I saw. That's how autonomous their manufacturing is. Mm-hmm. They have 3,000 overhead vehicles that move and pick up components and move them from lot A to lot B to lot C. And those 3,000, I think they said each one of those travels 92,000 miles in a year. They're just constantly moving. Absolutely fascinating, the science that goes behind the manufacturing, which leads to the architecture itself. Panther Lake, Clearwater, for those that have been wondering, is Intel going to be able to keep pace with the market? Without a doubt, 18A represents 2 nanometer-ish manufacturing process or manufacturing node. And the gains they're getting from performance and power efficiency perspective are absolutely incredible. I expect to see really good stuff coming out of Intel over the next 6 months to a year. But it's fair to say that Intel is certainly back in the game from a CPU perspective. Just wanted to kind of throw that out there. I know we're going to be going on, but if you guys want to really quickly weigh in on any thoughts.
Yeah, I think they've got the external customers, as far as I know, for 18A is Microsoft, Amazon, and DoD, I think, aren't they?
Mm-hmm. Yep. As well as themselves. Yeah. And there's talk of more coming for 14A. So yeah. Well,
how crazy, Matt, would it be? Because I know this has been in the news cycle as well. If AMD became a customer, I mean, that's like cats and dogs living together, man. I remember at Compaq, and I was doing commercial desktop PC product marketing, and then I left and I came back and did Rosario consumer, and we would always just pit AMD and Intel against one another, at least on the consumer side.
Oh yeah.
To basically make the vendor cry and squeeze them for MDF and margin and that sort of thing. And now, I mean, when you look at the x86, whatever you want to call it, consortium.
Yep.
Right. And the future possibility of their foundry building AMD parts, it's kind of crazy.
It's a different world. When I was at AMD, we actually sued Intel for, I gotta do my Austin Powers, $1 billion. I forget what we sued them for, but we ended up with a huge settlement because of monopolistic behavior.
There's actually been talks between AMD and Intel for manufacturing, hasn't there?
Yeah, that's where I was going. Yeah, and that's, I think
that's what I was alluding to.
And it's real. I mean, it was a real rivalry, and it was bitter. It's a different world. I think it started to change with Swan. It really changed with Gelsinger, and Hock Tan is really kind of moving the needle. And I think they both recognize that there are a couple of other threats out there, one named NVIDIA, the other named ARM. And that the x86 ecosystem has to be healthy if they're going to be competitive in the future. So it's good to see.
Yeah.
Wanted to go quickly over that. Congratulations to Intel. Keep it up, guys. Great to see.
Yeah.
Stock's doing well. Yeah.
Doing really well. Yeah.
Yeah.
Okay. Marvell's system development journey. I think this one might be Will's.
Might be mine. And I'm going to make this quick and make it a gratuitous plug for a research note that I recently published, and it's doing quite well. I mean, it's gotten several thousand views. So this is something that, I've spent a lot of time with Marvell to sort of understand what they're doing from a DPU perspective, interconnect perspective, and that sort of thing. Mm-hmm. And so I really wanted to write a sort of more of a landscape piece on system development. And, to boil it down, this is basically moving away from just the traditional, design and manufacture of discrete parts and putting things together to speed time to market and, focus on, power and all of that. And so, I mean, these are things that, NVIDIA and AMD are already focused on, but from an interconnect perspective, what I really like about Marvell and what they're doing is that they're leaning into system development to accomplish two things. One, it's around long distance optical connectivity and lengthening that transit point, and doing that through, again, a kind of a total package focus. Yep. And then and also focusing on encryption in the cloud and what they're doing with their liquid security HSMs. And it's all about, shrinking these devices, getting better efficiency and performance out of them. And so there is a research note that I posted to the website. So I'm going to be very succinct on my second topic this week and just say, go hit the Moor Insights and Strategy website and read more. But I found it pretty fascinating. And also another gratuitous plug, Marvell will be having an analyst day in December, 8th through the 10th. And Matt, you may be going. I'm certainly going. And our fearless leader, Patrick Moorhead, I believe, is attending as well.
You're a bastion of gratuitous plugs today. Good for
plugs. You. Yeah.
I need earplugs. Yeah, I'll be there. Interesting. It's people, when they think semiconductors, they think AMD, Intel, NVIDIA, maybe Broadcom, probably not Qualcomm for phones. They forget there's a whole market out there filled with the Marvells, the Astera Labs of the world that are doing so much, and that the really big companies out there, the Metas and the cloud companies, they are big customers of these companies like Marvell and Astera Labs, and by the way, they're the ones that drive the innovation upstream into the NVIDIAs and the AMDs and the Intels. So,
and it's often not the sexy stuff, right? GPUs are sexy, compute's sexy. I like to think, doing this for 9 years, that I've brought sexy back to networking. But
I think we need to go on to the next topic.
Let's move on. With that.
Paul, do you want to comment on Will being sexy in networking?
No, I think I'll skip over that one.
Yeah. Let's move on. Microfluidics. What the heck is microfluidics? Raise your hand if you know what microfluidics is. Okay. All right. Wow, Paul, I thought you would. So there is this, everyone knows that chips are getting really hot and really power consuming and generating a lot of heat, which is causing fans to not be as effective anymore and liquid cooling to come into play. And there are a lot of liquid cooling plate companies out there that do cold plates and run fluid through them to dissipate the heat or absorb the heat, transfer the heat from the chip. And that's been kind of the way the world has worked. Well, there's this concept out there called microfluidics, where you can take a chip, you can take an Intel chip, an AMD chip, it doesn't matter. You can take a chip, you can actually etch the back of the silicon, and you can push on like a leaf. You ever look at a leaf and you can see all the kind of the veins running? Yeah. it's the same concept. You do that on a chip and you run fluid through it, and you are able to cool the chip far more effectively because you're not going through 3 thermal layers to try and actually get to that heat. But it's not always worked because, man, you're going to etch into a piece of silicon and then run fluid through it. What are you, crazy?
Yeah.
Well, guess what? That's what Microsoft has done. It's been done in labs, but Microsoft has created a practice where they can do this at scale across lots of different chips, and increase that cooling efficiency or that heat dissipation efficiency by up to 3 times, which for those at home is about 300% more effectively than your traditional cooling methods are with liquid cooling. If you think about it, the way they etch, the pipes that they're etching in there are, I think they said it's about 7 microns in diameter, which is about the 10th of the diameter of a piece of hair. So super, super small. So micro really means micro. It should probably be nano, but super small. But they're claiming that the amount, and by the way, it allows you to get to where the heat is on the chip. That's the other thing with regular liquid cooling is it just provides a cool surface to sit on to kind of transfer that heat, but it doesn't go to where the heat density is, right? When you look at a chip, where the cores are active is where the heat is where those cores are kind of working the most, right? And those are small parts on the chip. It's hard to get to those. Super dense, super hot. So that's what's going on in the world. Microsoft is claiming they can do it at scale. They're implementing it into their Cobalt and Maya chips. And according to them, they are working with the silicon makers, the NVIDIAs, the Intels, the AMDs, to get this adopted more broadly at scale. This could be hugely disruptive for a couple of reasons. Number one, it can way cut down on power budgets in data centers, because now you don't need these big chillers, and you don't need to, the temperature of the water you need to run through there can go way, way up. And you don't need a bunch of pumps and everything else that's driving this water through these cold plates. That's number one. Number two, you can shrink down the actual size, and because you don't have cold plates. And number three, you can start to really embrace 3D architectures because you're able to get to those hot spots even further. Really cool. This is one of those, it's maybe not as sexy as talking about GPUs, but this is a pretty cool and disruptive technology if it takes off.
It's going to disrupt a lot of the data center management market, and more than just a couple of cooling companies. There's going to be some resistance to change too. So.
Oh yeah. I mean, look, every server company out there is trying to push their liquid cooling solution, and you literally have dozens of cooling solutions that have been adopted. You're right; it's super disruptive, but I'm kind of curious to see where this plays if it actually takes off.
Yeah. Hey Matt,
it will actually change how data centers are built.
Yeah, without a doubt. Yeah, without a doubt.
Yeah. Sorry, I talked over Paul. Hey Matt, does Microsoft intend to monetize this and license this?
There's a lot that's up in the air. I actually asked them that, and they cagily walked around that answer. They said they're working with partners for broader adoption. Okay. So I don't know. This could change how chips. Obviously, it impacts how chips are manufactured. But I mean, this could have impacts all the way down to like the TSMC, the Intel level, the foundry level. But yeah, they were very non-committal on kind of how they were going to handle that.
Okay. Yeah. Interesting.
Yeah. Cool stuff. Anyway, go ahead, Paul. Were you going to say something?
No, that's it.
Okay. Let's go to one more. We got this thing called, we have these two companies you might not know about called IBM and AMD. I don't know if you guys have ever heard of them.
I haven't.
They had a partnership, and Paul wants to talk about some latency issues that might kind of be introduced.
I don't know, but it's possible. Yeah, they've got a partnership. They're talking about a quantum-centric supercomputer, and that basically splits up the problems between IBM and AMD. Yeah, IBM's got specialized tasks, depending on what they're doing, like molecular simulation, and the classical supercomputer part of the hardware is being managed by AMD with their CPUs and GPUs and FPGAs and all that. So it'll be a new class of algorithms and computers and stuff, but there's some issues that they may have to overcome. One of them is the latency, communication, and orchestration, the bottleneck. A hybrid system has to have a way to send data back and forth between the QPU and the CPU and do it pretty fast.
Mm-hmm.
There's certain quantum algorithms, one is called VQE. It's a variational quantum eigensolver. That's a hybrid quantum classical algorithm. It's designed the original design is to find the ground state energy of a Hamiltonian that's the total energy of the system.
Mm-hmm.
But anyway, VQE sends stuff back and forth, and it's going to have to be done pretty fast, and it's going to have to be done like IBM in terms of how long they can maintain their coherence and stuff, which is just a couple of hundred of microseconds. So this is going to have to be done pretty fast. So I'm sure it's going to take a lot of work, but I'm sure they're going to be AMD and IBM are going to be successful at whatever they join on, I think. So.
Hey, Paul, real quickly, do you see this? So, do you see this as kind of this partnership as a kind of transitory step to a fully all quantum kind of world?
This is going to be the world. Is supercomputers are going to be quantum and going to be classical.
Yeah,
and they're going to have to work together. So,
do you think classical eventually goes away?
Pardon? No, I don't think so. No, we still need classical. You just got to couple the architectures together. So real-time control and feedback, and they've got quantum error correction to take care of. But that's going to be a new. We've talked to people here and I about what the world's going to look like with supercomputers and quantum.
But isn't it the case that you're always going to be limited by the kind of the slowest kind of chain in the or a link in the chain, or
depends on where the work is being done and what work is being done, and
okay,
what the architecture is. Quantum's going to handle quantum stuff, and classical's going to handle classical stuff.
Okay.
Yeah. And Matt, talking about, potential choke points, Cisco recently, they've always been working on a piece of silicon. I believe it's a quantum entanglement chip, and I don't even know what that means. Paul, I'm sure, is very well versed on that, but
sounds good.
They just announced, sort of not only sort of their next generation of that piece of silicon, but also a complete networking software stack to go along with that, because just like with modern AI, and you're seeing the improvements in Ethernet and what NVIDIA is doing with you got to have the commensurate kind of interconnect for quantum. And so for our viewers and listeners, go hit Cisco's website, because it's quite compelling, and I'll be digging more into that. And, Paul and I have exchanged a few emails. I want to get him connected with the Cisco team as well, because what they're working on is pretty fascinating stuff. And it's coming out of that same Outshift incubation organization at Cisco that launched the agency Agentic framework into the Linux Foundation.
Cool.
So yeah, very cool stuff.
Very cool. Right on. Good stuff. Hey guys, we're coming up to the end of the hour, unfortunately. Let's finish up with kind of what we're doing over the next few weeks. I know we've been kind of heads down traveling, and I suspect there's a little bit more going on.
Yeah, Paul, where are you going?
Next week, I'm going to Dell for about 3 days.
Okay. And what are you doing at Dell?
I'm looking around. Yeah, no,
Oh, is this your analyst summit?
They put on a really good event, and you get briefed on just about everything they've got in depth, and then you got access to everybody. So
yeah,
it's
Right
great.
on. It'll be fun.
Yeah.
I also want to say, just mention John Martinez is one of the 3 that won the Nobel Peace Prize in
Oh yeah.
physics, and he's really a brilliant guy. He's brought over to Google. Google brought his whole group over from University of California, Santa Barbara.
Oh wow.
Yes, and I think there were probably like 30 guys they brought over, and then they built a Google chip with all the controversy about quantum supremacy. They had 53 qubits, and IBM had some problems with it, and went back and forth. But it really gave everyone a good start on quantum computing, I think.
That's
John
pretty
is a brilliant guy, and
congratulations to him.
Yeah, and you spent time with him, Paul, right? And you've written about that, and yeah.
I've got I talked to him, I don't know how many times, but a number of times, and the one really interesting one was when he quit Google. It was like an 8.0 on the Richter scale for the quantum environment. But he was very open about why he did it, and I published the whole transcript, and it's still on Forbes. But it was interesting. The initial reporting of why he left wasn't exactly. I think the interview in the transcript straightened it out. I was just going to publish a regular article, but after talking to him and everything, and he agreed just to lay it all out for everybody to read.
Wow, that's pretty cool.
It's an interesting study.
Mm-hmm.
Very cool.
Yeah.
Hey, well, what do you got going on?
Man, my October is like bananas, right? So I'll be with Dell next week for a couple of days, and then I'll be heading to New York. HPE is doing a securities analyst summit, but they're inviting 3 or 4 industry analysts, and I was lucky enough to be included in that. So, looking forward to spending time with Antonio and Rami and the executive leadership team there. Following week, I'm actually going to a Gartner symposium. This is crazy. So. I've been a judge for the T-Mobile for Business Unconventional Awards. They've moved that from Mobile World Congress Las Vegas to this Gartner Symposium. So I get to go back to Orlando twice.
Oh, lucky you. Yeah.
I can't wait. It's like romper room at that Orlando airport when I flew out last night. Crazy.
It's like a Greyhound bus. It's like a Greyhound bus station. That's what it is.
Yeah, we were chatting about that over DM, right? Yeah. And then, I leave directly from Orlando. I go to Riga, Latvia for the Techratory event that I do, not keynotes, but I do panel moderation at. And then Fortinet slipped in an analyst summit at the end of the month. And then, my November, I've got Tokyo with NTT and a couple others. And so it's just, October is just bananas for me. And I know you're going to be at an Oracle event next week, right?
Yeah. So next week there's 3 things going. There's 4 things. There's Dell. There's Oracle Cloud World and AI Summit. There, NetApp has its Insight. Is that what it's called? Their user conference. It's not Insight. Ignite, their user conference, and there's also the OCP Summit, Open Compute Summit.
Oh, that's right. OCP is next week as well.
Yeah. I'm going to be at Oracle Cloud World, jumping into seeing what's going on in that crazy land. They're doing so much over there.
Rocket ship. There's so much going on over there with OCI and everything else, right?
Yeah. We're also going to be doing a week after that is Lenovo's Industry Analyst Summit, so I'll be attending that. I'd love to be at the Dell thing. I can't. Lenovo after that, and I think after that we're at Cisco in San Diego. So,
Partner Summit. So I'm looking forward to that in early November.
So lots of stuff going on. Anyway, hey guys, great chat. I know we have a hard stop at 11:30. We're hitting it right on the dot.
Cool.
Fantastic chat. Thank you for your insights today. And again, for those that are listening at home, like and subscribe. Please, whether you liked it or not, like and subscribe. And don't take anything we say as investment advice. If you do, shame on you. And we're going to publicly shame you. Thanks so much, guys. And we'll talk to you in a couple of weeks and have safe travels.
Yeah, you too, buddy.
All right. Thanks, guys.
Bye.
You guys.